This is what we'll talk about. We'll introduce agents. We'll talk about what agents are. We will introduce a very, very popular paradigm for building agents called ReAct. Now, there are a lot of other paradigms that exist. There are a lot of other paradigms. Reflection is a paradigm. So we will start off with agents. And this is the basic concept we will cover. And I'll give you enough ideas in terms of how to design agents using other paradigms also. And we will also see an end-to-end use case. It will be a very demo-heavy session. 5 to 10 minutes of slides we will talk about, concepts we will talk about, and then rest of it, the next 1 hour will be all agentic, very, very interesting agentic demos we will see. So that's the plan of action. So what I wanted to start out is a very practical application. All of you can see on the screen. It's a very practical application that I'm sure each one of you in the audience can relate to. How in the real world, you will have a database, right? Let's say you have a database. You have a database which consists of customer information, and you want to write a query. You want to write a query and get an answer. This is the exact same question some of you were asking me yesterday, that Stein, I have a similar use case where I have a database where I have a lot of tables and a lot of data about customers and transactions and orders and whatnot. And what you want to do is you want to go and query from the database in natural language, and you want to get an answer in natural language. Natural language could be anything. Now here we are talking about English, but it can be any language. So this is the end result or the end result of what we are trying to achieve. One of the results. There are a lot of other things we will be seeing, but one of the applications of agents is doing something like this end to end. If you see what we have done so far, what we have worked on so far, the large language models, they are not thinking engines. The LLMs are, they are language models where you give them some input prompt and they will generate a response based on whatever input prompt you're providing. And which is where we spend a lot of time in curating the prompt, fine-tuning the prompt. We have to write a very detailed system message. We have to write a very detailed user message. We spend a lot of time discussing those pieces. But one very important aspect of the large language models is they will not do everything end to end, right? If you want to build a complete application, the complete application is not just text generation. The complete application is not just classification. There are lots of moving pieces in the application, right? So think of agents as an automated way of doing all of those things. So large language models are only text in, text out systems. You give it some input text and they will generate some output response, but they will not take actions on your behalf. They will not think and do something for you. Now, agents are a complete package. What is powering them are large language models. There are LLMs that are powering them. LLMs are the brain behind it, which we'll see. But they are the complete package. And let's see what I mean to say by that. So in a very simple way, an agent is nothing but LLM plus tools. Now, as I told you, the large language model is the brain. This is the processor. So you can think of it like the manager. So the analogy that I like to take here is this is the manager. So the LLM is like the manager. So the LLM is like the manager. And the manager is a very, very well-trained and very powerful manager. So the manager has a lot of knowledge about different things. But the manager cannot do everything by himself or herself, right? The manager needs a team. They need a team of developers, architects, testers to get things done, right? So think of the large language model, the GPT-4 Omni model, as a kind of a manager. The manager itself cannot do everything, right? So the manager will need access to tools. So tools are the workers. So tools are the workers which will be used to get the things done for the manager. So the workers will work in tandem to get things done for the managers. So the tools are the workers. And these are the example tools that I've listed out for you. Search engine, Python runtime, database. So what it means is that you are giving the large language model ability to connect to a search engine like Google search, Yahoo, whatever. Okay. You are giving the ability to the large language model to connect to a Python runtime to run some Python code. Okay. So you write some Python query and the large language model will be able to run it for you. You give it access to connect to a Python runtime. And then you also give it access to connect to a database. So you give it connectivity to some kind of backend SQL Server database or Oracle database, whatever. It could be a SQLite database. Okay, there can be other kinds of tools also. You can have a tool where you allow the large language model to connect to Yahoo Finance API or some weather API. Okay, some kind of weather API to get the live weather data. Okay, another example of tool could be you connect it to the Yahoo Finance API. This is the one that we will use in the live end-to-end demo today. So we will actually use a large language model to connect to the Yahoo Finance API to get the live stock information. Another example could be you want to use a large language model to connect to the news API to get real-time news information. These are example workers. So the large language model, the GPT-4 Omni model itself cannot do everything. Because remember, very, very important, the GPT-4 Omni model was trained latest as of 2023. Okay, it was released in 2024, but the knowledge cutoff was 2023. Okay, so it only has data latest as of 2023. So it will not have access to real-time information. If you ask it some questions, the GPT-4o model will not be able to give you answers to those questions. It will not be able to give you the real-time information. The real-time answers will not come out. And that is an important thing to keep in mind. So then how can you augment the ability of the large language model? So the manager itself is quite good, but the manager will not be able to do everything. The manager doesn't have latest information. So the manager will need the help of workers. So there is worker one that will connect to the search engine, worker two that will connect to the Python runtime. And like this, there can be hundreds and thousands and tens of thousands of workers that can be connected. And if the manager wants to get something done, the manager will have enough intelligence to know, given a task, which worker to ask, which worker to call, or in other words, which tool to call. We call it a tool calling agent actually. The tool calling is another kind of agentic paradigm. So all that the LLM is trying to do is given a user query. So you can see here the user asks a question, how many customers have subscribed to the term deposit? Given the question, given the user message, the LLM will be a normal LLM, right? You have a user query, user message. LLM will have its own system message, prompt parameters, all this is standard stuff. Now the LLM will have an inherent ability to understand based on the user question, what tool to call. I have access to thousands of tools. I have thousands of tools at my disposal. So now I can decide which tool to call. Out of all the thousands of tools, I can decide which tool to call to solve the problem. And that's the way how you think of an agent. So it will call them in a sequence. Or let's say, first to answer this question, the LLM understands, okay, this is the question. This is something to do with customer, something to do with term deposit and all that. So to answer this question, I need to connect to a database runtime. I so the answer to the question will not come from Yahoo Finance or weather or news. So the language model should have enough understanding of that. That which workers I need to connect to answer this question. That is the first part. Once you figure that out, you call that relevant tool. Okay, in this case, you see what we did. We went to the database runtime. It actually identified the SQL query. What is the SQL query? It composed that. The query was run. The output was presented in natural language. So this entire set of things were happening. And the large language model was controlling the entire execution. Now, this is a very simple use case, but agentic systems can be a lot more complex. Now, in this case, we used only a single worker. We only used the database tool. But in reality, you can have an agent which uses multiple tools simultaneously. So it could be that you are using some database tool, and after the output comes from the database tool, you will have to call a Python runtime. So you need the results of a SQL query and also a corresponding Python command. Both has to be executed together for the final outcome to be generated. So in that case, the language model should take the call that, okay, given the user query, let's say I ask this question, how many customers subscribe to the term deposit, and like whatever, what is my latest stock price of Apple, something like that. Okay, you want to find some correlation between customers subscribing to term deposit and latest stock price of Apple. So the moment you ask that kind of a question, the language model will understand that to solve that problem, I need to connect to a database runtime, and I also need to get the latest Apple stock price from the Yahoo Finance API. So both these workers will be triggered. Both these tools will be called. Tool calling is what we will do. We will get the answer, and the LLM will present the final answer. So you can see the ideas are very similar. The ideas of agents are very similar. It's an extension of everything that we have talked about, right? So they're doing some kind of a retrieval and all that. Okay. and it's just a complete end-to-end package. Okay, and the reason why agents are like such a big topic and such a big exciting area today is because they are as close as we have ever gotten to a truly intelligent agent, truly intelligent AI system, right? Because historically, we had that beautiful introduction we discussed on the first day, right? AI, rule-based intelligence, expert systems, how we evolved from there, how we evolved from expert systems to machine learning, deep learning, and now we have generative AI. And specifically within generative AI, agents are a very, very exciting topic. And the reason is because they are really intelligent. They are as close as we have come to, true general artificial intelligence. Okay, so this is why it's so powerful, because you can literally have them do everything. You can literally have a agent do everything. So you can connect to multiple tools and it will do everything for you. Okay. And just to connect the conversation a little better, with some of the things we have discussed in the session so far. If you remember, we talked about Chat GPT. We talked about a lot of other things. So these are all agentic systems. So next time you log into a Chat GPT and you write a query, what you're actually doing is you're calling an agent. See, this is by default a GPT-4 model, right? So if I go and ask the question, what is the latest news? What is it doing behind the scenes? Think about it. Behind the scenes, there is a GPT model that is running. If you go and ask the same question to your Azure portal, Azure GPT-4 Omni model, it will not be able to give you the answer because that's just a language model. But the moment you browse it through chatgpt.com, this is actually an agentic system. This is not just a language model. What you are browsing right now is an agent. This is an agent that is connected to multiple other moving pieces behind the scenes. So behind the scenes, this is connected to many other extensions are there and all that. So unfortunately, I don't have the GPT Plus to show you. But if you have the GPT Plus subscription, you could actually you actually have an option to connect to multiple other Explore GPTs and all that you can do. Right. So you have an option to go to Explore GPTs, and there you can actually see a whole lot of other things. Right. So if you go to Explore GPTs, you'll be able to kind of see a whole lot of other options. So I just wanted to show you briefly what Explore GPTs I was talking about. You see a lot of Explore GPTs are there. So can you see we have got specific GPTs that are like if I go to productivity or lifestyle, I found there was something from Expedia actually. So if you can actually search for Expedia. So turns out Expedia there is a particular GPT for that. So what are these things? These are all extensions. So the moment you are browsing chatgpt.com, you are basically trying to access you are basically trying to use the underlying language model, which is GPT-4 Omni or whatever model that you choose to use. Okay, if you have the Plus subscription, you have more models available. And then at the back end, when you ask a question, the agent will decide what tool to call to answer that question. So in this case, I can ask a query saying, "Hey, get me the top flights from India to Dubai in the next 7 days." So my LLM will understand that to answer that question, I will have to connect to the Expedia API. So all these integrations are done behind the scenes, and that's what makes agents so powerful, right? I can show you. And Gemini is also a very, very powerful agent actually. So when you go to Gemini, it's also an excellent example of what we refer to as an agent. Okay, so there you actually have extensions, and what you can do is you can go to the extension section, and you can effectively go and you can enable Gemini to connect to all your stuff. So that's one of the ways how you can also work it out. Okay, so for example, I can take you to my Gemini. So this is my Gemini. All of you can see. This is my personal Gemini account, and so you can normally write your queries and all that, right? And what you can do is so you can actually go and go to settings, and you can go to apps, and once you go to apps, you can actually give Gemini access to all these things. And they've recently added GitHub. This is a very new inclusion. This was maybe hardly a few weeks old, maybe 1 week, very recent. So Gemini actually allows you to even connect to GitHub. How cool is that? How cool is that? You can actually, like, you can write a query, and Gemini will be able to retrieve the information from GitHub. So this is an agent. So whenever you access these models through these websites, what you're actually using is an agentic system. So this is a language model, and that language model has integrations, and through other extensions, it is able to call different tools. Like in this case, see Google Workspace. So if I ask it a question, Google will be able to. If I ask it a question, Google will be able to figure out Based on the question, Google will be able to figure out what tool to use to answer that question. So I can actually try out a query which says, okay, show me the top 5 finance emails. And if I do that, it will actually show me all my top emails from Gmail. It it will figure out of all the tools that are available, which tool to call. You can ask it questions with respect to Drive, questions with respect to Notes. Google Keep is for Google Notes, right? So the integration is very, very good. Even Google Flights, even YouTube for that matter. You can look it up. You can find out the top videos, what kind of videos you have watched. It's very personalized to your account. So what you're seeing here is again a true agent in a way. Okay, so it's quite exciting. Like some of the things that are possible and potentially some of the things that can be done with agentic systems. Okay, now let's get a little deeper into how do we design agents. What is the React paradigm? React is one of the paradigms that we will use generally. And this React is not your React framework. Okay, this is not your front end, it's not your web development, React.js, not that. So this is React, which stands for reason and act. Okay, so React stands for reason and act. This is a specific paradigm that we use for building agentic systems. So React is a specific paradigm that we use for designing agentic systems. That's a React paradigm that we use. Okay, and what are the different components of the React paradigm? So thought, action, observation. Okay, so React means reason and act. It's quite obvious, right? So first you think what you want to do, first reason. So you're given a problem. How do you solve a problem? First you think. First you think how you will solve the problem, and then you act. There are two steps to the whole puzzle, right? So first you reason, first you think what you want to do, how you will approach it. First you think, and then you act. So the React paradigm is completely based on that. So first you think what you want to do, and then you act on the basis of that. That's a React. And this is based on these thought, action, observation chains. Okay, so first you think what it is, what is the current state, what is the problem you are required to solve, what are the different options you have, how do you go about it. First you think, put some thought, then you act, then you take the action. Taking the action means you decide what tool to call. Like when I ask the question, what is the query and how many customers will subscribe to my term deposit? You first look at my question, first look at the query, and then you figure out what tool do I need to call to answer that question. What tool do I need to call? That's the way we go about it. So you decide an action, and then after you decide the action, you do an observation. You observe and you see what are the different aspects. So that's the way how we go about it. So thought, action, observation chain. So think, act, observe. Think, act, observe. Think, act, observe. Okay, and get the final solution. That's how we go about it. That's how we go about it. Now, what I will do now, now we'll see a small hands-on with respect to how this is done. And before that, I also wanted to show you a couple of beautiful animations to help us understand and solidify this concept a little better. It's always best way to learn things visually, right? So I'll show you a couple of very nice visual depictions in terms of how this is actually working. So let us see that. So there is this wonderful website called explainedprompt.com. Okay, this is a wonderful website which actually explains all the different types of prompting techniques. And I wanted to explain the idea of an agent through this particular site. And you can actually see a lot of the topics that we have already discussed. Like you can see zero-shot learning. So I talked about it. What is zero-shot prompting, right? So language models are zero-shot learners. You can see chain of thought prompting, how it happens. So language models are few-shot learners. This is also a beautiful demonstration where they actually show you that compared to zero-shot prompting, even if you give a few examples, even if you give it 2 to 3 examples, the performance of your language models will improve drastically. So this is a very nice visual way how the whole thing has been depicted. What we are interested in right now is this part, React. This is the agentic part we are discussing. But as I told you, there are different paradigms. There's something called reflection. There's something called tool calling. So multiple ways we can do it, but we will focus on React for the time being. So this is where the React framework is designed, has been explained very, very beautifully, right? So you can give it a read what it's talking about right now. This paper introduces React, a novel approach that combines reasoning and tool use in language models. Tool use, remember. So tools are the most important component of an agent. Okay, because underlying the manager is a large language model, the LLM. LLM is the one who has a thinking capability. That's the manager. Manager is the one who will juggle the resources. But what are the resources? Who will do the work? Who are the actual workers? The workers are the tools. So tools are the absolute, the most important component of an agent. Okay, so by interleave reasoning traces and actions, React is able to perform dynamic reasoning. Okay, so you can actually just this whole lot of text is there. So now let's come to the actual use case. Okay, so let us see how the React framework is working. Aside from the Apple remote, what other devices can control the program? App remote can control the program. App remote was originally designed to interact with. Okay, so this is a sample question from the hotspot QA dataset, which was used to evaluate the React prompting on question answering tasks. Okay, because ultimately I told you evaluation is very, very important. So there are a lot of benchmarks that are used for evaluation. So whenever any new language model is developed, a lot of these benchmarks datasets are used for evaluating the performance of these language models. So we have taken one of these benchmark datasets called the hotspot QA dataset. You can actually see if you want to. You can actually go and look it up what kind of dataset it is. So these are actually very, very popular benchmarks that are there. Okay, and a lot of the top models are usually tested on these benchmarks. Okay, this is just one example I'm showing you what benchmarks mean. Anyway, so this is the question that is asked. Now, what is the next step? Let's see. Next step. So solve a question. Uh, so this is the prompt that you will typically give, right? So the prompt starts with instructions for the model to follow thought, action, observation cycle of React prompting, followed by a list of available tools. Okay, so remember React is based on reason and act, and it is primarily the idea is thought, action, observation. You first think, then you act, then you observe what happened and what is the next step I have to take. It's a cycle, it's a chain. It's keep going on and on and on until the end happens. So that's the way how the thought, action, observation chain will work out. So you will to write a very detailed prompt. So let's say we write a prompt, and based on the prompt, you start with instructions. So you see solve a question answering task, it interleaving thought, action, observation steps. So thought can reason about the current situation, and action can be of the three types. So you're writing a very detailed prompt. You're specifying that okay, what is the meaning of a thought? Thought is the part where you reason, you think what is to be done. This is the prompt. This is the system message by the way. And action can be of the three types. So you explicitly specify what action the LLM can take, what action the agent can take. Okay, and what are the actions? First, you give it access to a search tool, and you specify what is the search tool going to do. Then you give it access to a lookup tool, and you specify what is the lookup tool going to do. And then you give it access to a finish tool. So this entire thing should be part of the system message prompt. Okay. Each tool definition shows how to call the tool and describes what the tool should be supposed to do. This is how the model decides which tool to use to answer the question. Okay. So when we define these tools later on in the demo, I'll show you how to design how to create these tools. It's very important, and these are actually Python functions. So when we come to the demo later, we will see that these tools are nothing but Python functions. Okay, so if you have a search tool, you will create a Python function for search, and you will also give a doc string for that function, which specifies what that function is supposed to do. It has to be a very well commented function, and the description of that function should specify very clearly what that function is supposed to do. The function should be described very appropriately. The lookup tool is the one that will return the next sentence containing the keyword, and the finish tool will return the answer. So you say, okay, this is what I'm supposed to do. Given the question, think how to proceed, and then act by using any one of the tools. Okay, that's the way. Let's look at one example. Let's look at one example how this will work out. Okay, this is one example, and complete end-to-end example we are seeing. What is the elevation range for the area that the eastern sector of Colorado extends into? Right. So this is the question that is asked. User message. So what will happen? Now this will be given to the agent, and the agent will start working. Remember, agent is LLM plus tools. So what is the prompt that is written behind the scenes? So first the agent has to think, okay? Or rather the LLM has to think. When I say agent, I mean LLM, okay? That is the brain of the system, right? I need to search the Colorado orogeny, find the area that the eastern sector of the Colorado orogeny extends into, then find the elevation range of the area. This is what it is supposed to do, right? This is the entire plan of action that has been created. Now let's see. Let's go to the next step. Okay, so you can actually go step by step if you want to do this along with me. Let's see. So search for Colorado origin. Okay, where will we search? We will go to Wikipedia and do a search. Right, so we can search for Colorado origin. Let me uh, let me show you on Wikipedia how this looks like. Actually, it's a great way to learn. It's a very visual way to learn how it's actually happening. You can see. See if I can show you in the same interface. See. Uh, so I'm searching for Colorado origin. I'm just showing you in the same window. And when I search, you can see. Look at the first line is returned. This is exactly what we are seeing on the screen, right? All of you can see. The Colorado orogeny was an episode of mountain building in Colorado and surrounding areas. Can you see? This is exactly what we are seeing on Wikipedia. So when we search, uh, we are able to return the first text. So thought, it acted, it used the search tool, it tried to find out about Colorado orogeny, and then it observed, okay, this is what was returned. Then the agent is thinking again that, hey, this is returned, which is fine, but it does not mention about the eastern sector. So I need to look up the eastern sector, right? Now, what is the eastern sector? How do you look it up? So what I can do is I can do a control F. This is quite literally how it is, okay? And it is searching for the eastern sector. Okay, so it is actually you can actually search for the eastern sector, and when you do that, you can see, look at this part. The eastern sector extends into the high plains, and it is called Central Plains orogeny. Can you see? This is exactly the text that is written here. The eastern sector extends into the high plains, and it is called Central Plains orogeny. All good. We return this. We return this. Again, the agent is thinking, okay, the eastern sector extends into the high plains, so I need to now search high plains and find its elevation range. So see how it is methodically figuring it out. And now what I will do, I will simply search for high plains and find out its elevation range. Okay, so I go and search this out. See, when I search for high plains, I'm not exactly getting the complete information. So rather, I need to search for high plains United States. Okay, so now you need to go and use a new search tool, not lookup. Lookup basically means that you're looking up in the same document. So now it figures out that I need to instead search for high plains United States. So go and search for this now. I will go and search for this now. This is going to be a new Wikipedia search I will have to do. So when I go and search for high plains United States, I will actually get the complete answer. The first, yeah, I will get the complete answer. Okay, and I will get the complete answer in terms of elevation. So that's the way how the entire thing will basically work out. If you see when I search for high plains United States, the complete elevation will come from here. Can you see? Look at the numbers are coming. See 1500 to 600. All this is coming up right now. So see how the methodical way how we went about it. So thought, action, observation. So first you ask the question, user message, agent thinks what to do, then it decides what tool to call to solve the problem, action, then observes again, then again acts, observe. So that thought, action, observation is continuing to go on and on and on until it stops. So that's the way how we go about it. And this is what is achieved using what we call a ReAct prompt.